Hi, my name is Larry Heminger. I'm Chief Technology Officer at a company called Automated Retail Technologies, or ART. ART is designing a global network of automated food kiosks. These kiosks are really cool. They serve a variety of food, all the way from frozen yogurt and ice cream to a variety of hot food like pizzas, cheesy pretzels, cookies, Cinnabons, all the way through a steak dinner. So we're designing some really cool kiosk technology, deploying those kiosks worldwide. And what I wanted to talk to you today about is a technology called MQTT. MQTT is traditionally used in the Internet of Things, or IoT, space, in order to connect together lots of things in a network. And what I wanted to talk a little bit about today is how we're using MQTT to implement this global network of automated food kiosks. So that being said, let me go ahead and share my desktop, and we'll get right on it. Okay. So let's start off and kind of define the problem a little bit. I don't know about you, but when I think of IoT, I think of small devices. I think of home automation. I think of intelligent light bulbs, smart door locks, my Ring doorbell. I'm an automation junkie here at home, probably like many of you are. And that's kind of what I'm showing in the top left corner here is kind of the traditional home automation environment. And that's where some of these technologies like MQTT kind of got invented and got their roots. The unique part about that environment is these devices are small footprint, very low amount of memory and compute capability. So that sort of an environment is very different from those of us who normally do web services and more enterprise scale applications. As it turns out, the IoT sort of technologies do apply to a wide variety of industries that I'm showing here: oil and gas, transportation, logistics. So just like you want to connect a global network of Philips Hue light bulbs, you'd also, in the same way, connect a global network of airplanes, trains, 16-wheelers, etc. So that kind of sets the stage for entering ART, where just like some of those other businesses, we have this global network of fairly large things that we're networking together. The difference being my kiosks don't typically move very fast, but there are lots of them. They are very large devices, and they are global. So that's kind of sets the stage for the problem that we're trying to solve. So kind of moving on to what is MQTT and why would I want to use it? So in a nutshell, MQTT stands for Message Queue Telemetry Transport. It provides an asynchronous, bidirectional publish and subscribe mechanism. As I mentioned, it was originally designed for the more traditional IoT space, where it's lightweight, small footprint, very low demands on memory and operating system features. It's super easy to integrate into a wide variety of applications. And also, as it turns out, it can be as secure and as reliable and as scalable as you need it to be. So what we're showing here in the diagram is the kind of high-level architecture of MQTT, where we've got a broker in the middle. All messages are transferred from publisher to subscriber through a third-party broker. That third-party broker can provide optional state storage. And again, the traditional model here is producer-consumer, with a broker handling the message traffic, in between. So why would I want to use MQTT versus doing it on my own? Well, there's nothing stopping you from designing, something similar or something more specific to the application. But the amazing thing about MQTT is it's been around a while. It's a public standard. By and large, most of the libraries and runtime environments for MQTT are open source, free, and it's super easy to integrate, and it's really agnostic to what your operating system is, what platform you're running, and how embedded that platform may be. So it can support everything from thick applications to where it really stands out and shines is in mobile and web apps, where you get some really, really interesting capabilities I'll build on here in a second. So that's kind of the what it is. When you think about MQTT, I know when I first took a look at it, it sounded awfully similar to another technology called Websockets, and many of you, I'm sure, use Websockets in your applications. So I thought it would be worthwhile just for a minute to compare the two technologies. So starting with WebSockets, WebSockets provides an amazing capability, particularly powerful for web-based applications where you've got that bidirectional web services architecture. So not only can my web client make a service call, it can actually establish communication to a server, and then it can then call out respond as a server itself. So the way I think of WebSockets is bidirectional web services, but with the same kind of a model where you may design many, many different web service endpoints that each serve a particular function, right? As it turns out, MQTT has its own protocol. I think it's 8881 is the port number, I believe, or 8883. You can actually configure MQTT to run on top of WebSockets in cases where you may be in an enterprise environment, a little more locked down, and you want to actually run it over port 80 and port 443. So it can also be used in that environment to where you don't have to open a specific port number. So in contrast, MQTT, again, is a publish and subscribe architecture. We do not have a direct communication from client to server. All communication takes place indirectly through a broker. And the great thing about that sort of an architecture is I don't have a point-to-point tunnel or communication pipe that I have to establish. I merely connect into a particular topic of interest, very, very data-centric sort of an architecture, and then publish or subscribe to that particular topic. So supporting almost a broadcast sort of capability where I'm publishing information once, and any consumer out there that is interested in that information can subscribe and get that real-time update. So to me, depending on the use case, that's a really, really easy to use and simple model, and requires a lot less infrastructure than a traditional kind of a web service architecture where you're establishing a direct connection between a client and a server. So that's kind of, from my perspective at a high level, kind of the way I look at the two technologies. Another interesting thing about MQTT is its ability to scale to your application. And so I kind of refer to that as dialing in your use case. So 3 specific examples of dialing your use case. First of all is quality of service. I can configure my message delivery within MQTT to be as precise as we need it to be. So, and they define it in 3 levels, 0, 1, and 2. 0 being delivering a message at most one time, level 1 being delivering a message at least one time, and level 2 being delivering a message exactly once. So clearly, being able to deliver a message exactly once is kind of more the TCP analogy, and it requires the most overhead, right? But if you've got more of a broadcast application and you don't care if someone maybe gets the message twice, or the occasional client, misses an occasional message, then you can configure it at the level 0 or level 1 and go that much faster. So dial in your quality of service. And directly related to quality of service is persistence. You can also configure how you want to deal with offline messages. You can configure the broker or the publisher to implement persistence. So if you've got a communication and maybe a publisher goes offline, it can then queue up the messages that need to go out. Once the network comes back available, it'll go ahead and send those queued up messages. So again, dialing in your level of resilience to network outages and things of that nature. It also has a unique feature called last will and testament, which is interesting. So in this network, unreliable network, so to speak, I've got producers and consumers running. Something crashes, right? We're software is not perfect. Occasionally it crashes, goes offline. You can configure either that publisher or subscriber to send out a last message, to publish the fact that, hey, I'm crashing or I'm going away, letting the other subscribers to that topic or the publisher of that topic deal with that situation. So I just calling that out because I feel like that's a very unique feature in this world of asynchronous messaging. And lastly, really dialing in your security model. MQTT can kind of scale to any given set of security requirements. At a minimum, it requires a client ID, which is just a shared secret, essentially, that allows you to establish a connection to the broker. But you can go way above that. You can use OAuth. You can use traditional login password. You can integrate with enterprise LDAP. You can create ACL lists for different roles. So it's got a very, very rich capability to integrate with whatever security model you need. But at the very root level, you can get started with it, very easily just by creating a shared secret to move forward with. So just a few examples of kind of dialing in your application. And then lastly, the major advantage of MQTT that I see is the lightweight and flexibility, of the software. Kind of looking at 3 integration points: mobile, thick app and services, and then the broker itself. It's got a wide variety of support for mobile, from native React to Java and Kotlin on the Android side, to CocoaPod and Cocoa MQTT on the iOS side. Thick apps, it has support for any major enterprise programming language, plus .NET and PHP and Ruby on Rails, and you name it, there's a library for it. And then lastly, on the broker side, you can go anywhere from open source to using AWS's MQ, for example, right out of the box. We have quite a bit of experience at ART using Cloud MQTT, which is a third-party SaaS-based product, very, very low cost. That's really the only cost associated with MQTT that I've experienced so far, is just a monthly fee relative to the broker. And if I didn't like that, I could go use an open source. Okay. The other thing I just wanted to point out is the opportunity that MQTT enables to implement what I refer to as a callback architecture. And so this would be a scenario where you kind of, maybe you have a one-page, either a mobile app or a web app, and this gives you the ability to do real-time updates on that page without ever having to refresh the page or refreshing your data model. So all you're doing is you're connecting UI components on your page with a change in a message. And it's that simple. It requires very few lines of code. And all of a sudden, I've got a real-time capability that I can display to my users. So I'm showing React on the right-hand side of the slide. The top sample code is an example of sending a message on a topic from a client. The bottom example is an example also in React of subscribing and reading a message and then updating your UI. So very, very simply, in the bottom example, you'll see a line that says client equals connect. That's basically establishing a connection to a topic on a given port, and you're getting an object back for that. You're then subscribing to that topic. And then you'll implement using the React action to then define an action for receiving a message and updating some UI. In this case, they're only outputting a console log message, but that could easily be updating a table, adding a row to a table, updating a chart, updating a graphic, all sorts of cool stuff you can do with very, very, very minimal amount of code. So the money slide here, when we get right down to it, is how is ART using MQTT in our system? And I understand this is a busy slide, just pointing out a few things. So our kiosks are shown at the bottom. There's a variety of brands of those kiosks. They all publish and subscribe to various MQTT topics. We are using Cloud MQTT, again, a separate service, very, very inexpensive, very reliable service. So all communication goes through that broker. And then we have kind of 2 categories of client apps. We have mobile apps that we're showing on the right, and we have web-based website that we call Operator Portal that we're showing on the left. the way we're using MQTT in the case of the mobile, the leftmost screenshot is showing a list of kiosks. You tap into a kiosk that then subscribes the mobile app to topics that will be used to populate the inventory, populate the prices, populate other aspects of the visual that you see there. In this case, we're showing our frozen dessert kiosk. That's a frozen yogurt that you're seeing in that cup. So we're able to very, very quickly establish an indirect communication to that particular kiosk and complete a consumer transaction based on that data. Very similar use case on the left-hand side with the operator portal. Here we're diving into transactions. You're able to look at telemetry that we're subscribing to telemetry messages from the kiosk, looking at the health of the kiosk, detail, requesting logs and things of that nature. So this has enabled ART. We're a small company. We don't have a huge team of engineers. This has allowed us to develop some very sophisticated, very capable applications, again, without a huge investment in infrastructure and a huge investment in engineering resource. I should also mention that we're using a package called the Eclipse Payho. And so that is a open source package that supports both the AngularJS environment, which we're using on the portal side, and supports the native React development environment on the mobile side. So that's kind of what we're doing at ART. And just to wrap up really quickly, again, if you have an application that could potentially leverage the publish and subscribe paradigm, so to speak, this MQTT thing is scalable, lightweight, secure as you need it to be, reliable as you need it to be. It's the right price, pretty much zero except for the commercial brokers that you may use. It also has a wide variety of monitoring and other tools associated with it. What I'm showing here on the screenshots are two monitors. They're both Google Chrome plugins that allow you, again, they're both free, allow you to enter in your broker and your client ID and then browse and receive updates on whatever topic you're interested in, basically to debug and diagnose your publish subscribe communications. So kind of everything you need kind of out of the box and allows a small team like ours to kind of get rolling very, very quickly. So that's a super high level of MQTT. I hope it was informative. Please have a great day. Thanks.